this detection came out of phosphine, which is, a phosphorus atom attached to three hydrogen atoms. And it's not a particularly well-known species, not really talked about a lot, but it is made by certain organisms, microorganisms on Earth. And it's not really produced any other way other than on Earth, at least other than by life. So what they did is they found this. They took two different telescopes, James Clerk Maxwell Telescope and the ALMA telescope, and they observed Venus's atmosphere, and they found the signal using both telescopes. And the James Clerk Maxwell Telescope observation looked okay, but it was kind of weak. And then the ALMA one, which is like 66 antennae, it's essentially working like a 15-kilometer size telescope, because it's got like all these different dishes at different distances. Gets this excellent, I'm not an observer, but to me, the signal looked amazing. It was just so clear, so strong. And then they ran some models to try and figure out, okay, well, what kind of abundance is this? And they kind of settled on 20 parts per billion. And then they looked at the chemistry and they said, okay, well, there's actually no way that chemistry could make this amount of phosphine. And there's no way that the physics of the atmosphere, the mixing and stuff could build it up either. So what if we put in an unknown source of phosphine at about 50 kilometers up in the atmosphere, and then rerun our models? Oh, now we can get this signal. So now now this unknown source is kind of this evidence that one of the things it could be is life. So that was really exciting. But then in the process of science, it's like now the scrutiny starts, and it seems like it was just piled on for the next 2 months onto this team. In some ways, in at least a couple ways, a little bit unfairly too, just in the language that they were using. But they essentially were scrutinizing the detection itself and the way that you process the data. And this is where it's really hard to explain, and I'm no observer, so I can't really do it justice. But essentially, you got to fit your data sample, or your data that you get. You got to fit it to try and pull the signal out of the noise. And in doing so, you may be introducing a signal that wasn't there in the first place.